this lesson, we'll talk about Wiley Section 8-1, Light in the Bohr Model. We'll talk about the electromagnetic spectrum, go over the Bohr model, some advantages, disadvantages, and the significance of this step forward in atomic theory. So what do all of these have in common? Visible light, infrared, ultraviolet, microwaves, radio waves, cosmic gamma, and X-rays. Well, it turns out that all of these are all made of photons. They are all part of the electromagnetic spectrum. Here's a picture of the electromagnetic spectrum, and it covers a tremendous range of values. Another thing to note about this chart is that the visible spectrum, the wavelengths of light that we can detect with our eyes, is actually very small. It's a small part of the total spectrum. From the electromagnetic spectrum, we'll go to the Bohr model. In 1922, Niels Bohr won the Nobel Prize. He explained the relationship between light, electrons, and atoms. It was a huge step forward in scientific knowledge. Bohr worked with Albert Einstein. He also was part of the Manhattan Project, which made the atomic bomb in World War II. There's a picture of Niels Bohr. Him and Einstein hanging out. So when a sample of hydrogen is energized by heat or electricity, it gives off a unique series of light, a series of unique colors. And Bohr tried to explain this spectrum. There's a sample of what it looks like. We see red, teal, blue, and a faint violet. So why these lines and why the spacing? Notice that the spacing is not even as well. Bohr thought that electrons orbited the nucleus at different distances. Low energy electrons were close to the nucleus. High energy electrons were further away. If an atom were energized, the electrons might move from a lower to a higher orbit. When an electron falls from a high energy state to a low energy state, then light is emitted, and that's the light that we saw from the hydrogen spectrum. The energy of the light matches the energy difference between the two levels. We see no energy unless a complete jump between levels occurs. There's no half jumps in energy. Let's look at a figure on this. If we've got an electron that drops from the second energy level down to the first, then we see a photon of light emitted. That's what that H nu means. If we have a larger drop in energy from a higher energy level on down, the light that is emitted is higher in energy. Larger drop equals higher energy in light. That represents the spectrum that we see. The different lines represent different transitions in energy levels. And the energy levels are fixed, which is why we only see those specific wavelengths of light. So the Bohr model was an improvement of what they knew previously. Rutherford had postulated that all the electrons were at the same distance, while Bohr says no, different electrons are at different distances from the nucleus. The Bohr model correctly predicted the different energy levels that exist in atoms. He used hydrogen, but those energy levels are correct for other atoms as well. Now, the Bohr model did have some problems. It doesn't work for systems with more than one electron, and that reason is the electrons repel each other, and our math is not able to predict those interactions between the negative charges and the positive nucleus. They call that the three-body problem. And some of the Bohr model is wrong. Electrons do not orbit the nucleus. They're not like planets. We'll talk more about what electrons really do in the next lesson. Also, and this is very important, the Bohr model defied classical physics. According to classical physics, the negatively charged electron, rather than just orbit like a planet, should spiral into the positively charged nucleus. So to address this problem, Bohr said, well, the normal rules of physics don't apply to these small, infinitely tiny particles. It seemed arbitrary at the time. It seemed as a band-aid to just fix a flaw in Bohr's model. But it turns out to be the basis for quantum mechanics, and that was later verified. Bohr was criticized at the time, but later on was proved to be right. So today we laid the foundation for our electronic energy levels. We talked about the electromagnetic spectrum, the Bohr model, advantages and problems. If you have questions about this material or any other material, of course, contact Corey or myself, your course mentors. Next lesson, we will talk about electron configurations and how the Bohr model ties into that. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.